Hey everyone, today let's solve a limit problem together. It might look a bit complicated at first, but don't worry, let's do it step by step. So the first step is we always want to do a direct substitution. So let's plug in x equal to 2. We would have 2 to the 6th power minus 64 over 2 minus 2. And here we get 0 over 0. 0 over 0 is also called an indeterminate form. Means we don't know the limit at this moment yet. So let's try some other method. So the second step is to recognizing the structure. When you have a fraction that you want to calculate limit, and your numerator has a higher power than the denominator, what you always want to try first is factoring. So you can cancel out the common terms. Here we have x to the 6th power minus 64. We're going to use the classic equation here, a squared minus b squared is equal to a plus b times a minus b. So x to the 6th power minus 64 is going to give us x to the 3rd power plus 8 times x to the 3rd power minus 8. And that's also equal to x to the 3rd power plus 8 times x minus 2 times x squared plus 2x plus 4. If you forget the equation, you can also use long division as well to get the result. And now we have x to the 6th power minus 64 over x minus 2 is equal to x to the 3rd power plus 8 times x minus 2 times x squared plus 2x plus 4. So we just moved whatever in here down over x minus 2. So for factoring, we always want to cancel out the common part, so we don't have a denominator anymore. And now our limit question becomes the limit as x goes to 2. And our equation becomes x to the 3rd plus 8 times x squared plus 2x plus 4, which is these two parts over here. And now we can plug in the 2, which gives us 2 to the 3rd plus 8 times 4 plus 4 plus 4, which gives us 16 times 12 is equal to 192. And that will be the final answer for this question. And if you have learned how to take derivative and L'Hopital's rule already, there is another way to solve this problem. And the reason we can do that is because we have an indeterminate form. So we know that we can apply L'Hopital's rules to figure out the limit. So for that rule, it says if we take the derivative of the denominator and the numerator separately, then we shouldn't change the limit. So what we do here is we take the derivative of the top part. Derivative of the top, we get 6x to the 5th power minus 64 is a constant, so we don't need to include that. And for the bottom part, the derivative for x minus 2 is equal to be 1. So by using L'Hopital's rule, we know that the limit for our original equation is also going to be the limit of function x times x to the 5th. So now, since we don't have an indeterminate form anymore, we can directly plug in x goes to 2 into our new equation. Limit of x goes to 2 of 6x to the 5th power is equal to 6 times 2 to the 5th power, which is going to give us 192 as well. So notice here we got the same answer for using both methods.